Hi, this video is about option Greeks. We have seen already that there are different factors which affect the price of an option. Now, option Greeks is a measure as to what is the impact of those factors on your option prices. It is going to give you in terms of numbers as to if a particular factor is changing by certain amount, how much will that affect the option price. You have five different types of option Greeks. They are delta, gamma, vega, theta and rho. We look at each of these Greeks now. The first one is delta. Delta is nothing but the measure as to if the underlying asset price is going to change by 1 rupee, how much will the option premium change? So that is the delta measure. For example, let's take that there is an asset which is priced at rupees 100 and there is a call option which has a strike price also at 100 and currently a premium of 20 rupees. Now, when the asset price is moving from 100 to 105, let's say that the premium of that call option from 20 changes to 23. So if you look at the delta of this option, the change in premium is in 3 rupees where the change in asset price is 5 rupees. So which means that for a 5 rupee change in asset, the premium is changing by 3 rupees. So the delta of this particular option is 0.6, which effectively means that for every change in 1 rupee or for change in 1 rupee of the underlying asset, the option premium is going to change by 0.6 rupees. So that is the understanding that we get from the delta measure, and this delta ranges from 0 to 1 for call and 0 to -1 for put. Why positive for call and negative for put? If you take a call option, as the asset price increases, the call option becomes more in the money. So the premium of that option will increase. Hence, the delta is positive for call. But for put, as the asset price increases, the option premium will come down because the option becomes more unfavorable. So hence the value of negative for put option. Depending on the moneyness of the option, the delta values will also change. For example, if you take an in the money option, an in the money call option will have a delta which is closer to 1. It could have somewhere between 0.8 to 0.9 and values like that. If you take an out of the money call option, then the values would be closer to 0, and the at the money option will have a value which is closer to 0.5. Similarly for put, if it's an in the money put, then the delta values will be closer to -1, and out of the money options will have a value closer to 0, and at the money options will have a delta value closer to -0.5. And as the time to expiry also changes, if you look at this, the delta when the time to expiry is more, the delta will behave in this fashion. Okay, as at expiry, at the time of expiry, all the out of the money options will have a delta which is equal to 0, and all the in the money options will have a delta which is equal to 1, because at expiry the time value becomes 0, and in the money options will have only the intrinsic value and not the time value in the premium. That is the reason why at expiry the delta of in the money options become 1 and the delta of out of the money options become 0. The next Greek is gamma. Gamma is nothing but the rate of change of delta. If you look at an option, the delta of an option will not be the same throughout. It's like the delta of the option changes depending on the change in the asset price. Okay, for example, let's say that let's take this example. Okay, there is an asset which is priced at 100. Okay, and the strike price of a call option is also 100. So when the strike price is 100 and the asset price is also 100, let's say the premium was 20, and since it's an at the money option, we are assuming that the delta was 0.5. Now let's say that the asset price from 100 moves to 105. When the asset price moves to 105, the premium from 20 is changing to 23. Okay, now if you calculate the delta for this change, the delta will be 0.6. Okay, now let's say that the asset price is now changing from 105 to 110. Again, there is a 5 rupee increase in the asset price, but the premium is increasing by 3.3. Now, if you calculate delta for this, the delta value is 0.66. Alright, now from delta zero point 0.5 to zero point 0.6, the change in delta was 0.1. From delta 0.6 to 0.66, the change in delta was 0.06. And similarly, if you consider the next stage, the change in delta is 0.04. Okay, so if you look at this, the delta values are changing and the rate at which the delta is changing is also changing. Okay, this change in, or this rate of change in delta is what you call as gamma. How fast the delta is going to change. Okay, that value is given by gamma. Generally, the gamma is high for at the money options, because at the money options have larger time value compared to out of the money and in the money options. Okay, so this is how a gamma would behave for an option. Out of the money options will have lower gamma, whereas at the money options will have higher gamma, and as it moves to in the money, the gamma will come down. Okay, and the gamma is mostly positive value. But if you look at delta, you had negative values for put, but whereas gamma is positive value for both call and put. As the time to expiry changes, the change in gamma would look like this. Okay, when the time to expiry is longer, the at the money option will have higher gamma, but not as high as when the time to expiry is low. The green line indicates the gamma when the time to expiry is lower, and the red line indicates when the gamma or when the option or the time to expiry is higher. Okay, so this is how a gamma would react to a time to expiry and also to different moneyness of the option. The next option Greek that we are going to look at is Vega. Vega talks about the impact of change in volatility on the option price. The impact of Vega is more when the time value of the option is high. So if you look at the money options, they have the highest time value. So the Vega values are high for at the money options. Okay, and also when the time to expiry is larger, the time value of the option is also larger. So the Vega values are high for when the time to expiry is high, and this green line indicates when the time to expiry is low. Okay, as you approach the date of expiry, the Vega values also come down, but their values are high for at the money options compared to out of the money or in the money option. The next option that we are going to look at is theta. Theta talks about the time decay that will happen in an option premium. We know that any given option premium will have two components in it. One, the intrinsic value, and the other, the time value. So the time decay, or the measure of impact of change in time to expiry, which is called as theta, will be generally higher when the time value is higher. So the time value is higher for an at the money option. So generally the theta values are higher for at the money options compared to out of the money or in the money options. And if you look at this diagram, if you look at this area, the green line represents when the time to expiry is lowest, and the red line represents when the time to expiry is highest. Okay, for an out of the money and in the money option, as you approach expiry, the time value in their options will come down or will be very low. So the change in premium because of the change in time to expiry will be very low when compared to at the money options. At the money options compared to out of the money or in the money options, generally they have higher time value, but during expiry or at a time when it's very close to expiry, the time decay that is going to happen for an at the money option will be much larger when compared to out of the money or in the money options. Hence, if you look at the green line, the value of theta is much larger for an option which is close to expiry than an option which is quite far from the expiry. So this is how theta would behave. Theta generally has a negative value because we know that The time as the time to expiry approaches, the time value in an option will come down. So theta is always negative. The final Greek that we're going to look at is rho. Rho generally talks about if the interest rate changes by 1%, what will be the impact of it on the option price. Compared to other option Greeks, this is a Greek which is not given too much of an importance. So all that you have to remember is that this talks about the impact of interest rate on the option price.